Okay, in this video, I'm going to talk about what's known as your basic right triangle trigonometric ratios. So they're called I'll say trig instead of trigonometric. I'm going to stumble on that eventually. Trig ratios. Ratios meaning fractions. Now, there are three main trig ratios that we're going to talk about today. There's others, but we're just going to talk about three. They are called sine, cosine, and tangent. Here's the words spelled out. Sine, cosine, tangent. They're always abbreviated SIN, COS, and TAN. So, gotta pause a minute. I gotta add something to this picture. Okay, I wanted a right triangle on here so we could talk about those. Now, if you have any right triangle with acute angle. An acute angle is something smaller than 90. So think about if you have a right triangle, this angle and this angle, I'll erase that for a second, are acute. They're less than 90. Because the three angles together have to total 180. If one of these angles is 90, 90 and 90 is 180, two angles can't be 180 because that leaves no room for a third. So either of these two angles are acute. This weird symbol looks like an O with a horizontal slash through it. That's called theta. Theta. It's a Greek letter. Think of it as X. It could just very well be X. But it's very typical in trigonometry to use that weird letter. So it says in any right triangle with acute angle theta. I'm going to put that here right now. Meaning I want us to look at that angle in a few minutes. Here is what the definition of sine, cosine, and tangent are. Actually, we'll get to that in a minute. Let's label this triangle. I want to label the three sides with the following labels. One of the sides is going to be called the opposite side. One of the sides is going to be called the adjacent side. And the third side is going to be called the hypotenuse. Now, I'm actually going to write the hypotenuse first because the hypotenuse is always in reference to the right angle. Across from the right angle is the hypotenuse. It does happen to be the longest side in the triangle. So the right angle is right here, meaning two sides make the right angle. The third side across from it is the hypotenuse. That's this one. Okay, so there's our hypotenuse. Now, the other two labels, opposite and adjacent, they are in reference to wherever I place this theta, meaning what acute angle do I want you to look at right now? I want you to look here. Now, I find I have more success with students know what the word adjacent means. Adjacent means next to. If you look at an angle, two sides are next to it. Two sides make it up. Okay? This side and this side and this side. But that side's already labeled hypotenuse, so it can't be called adjacent, even though it is next to. This side is adjacent. Because it's right next to and touching that theta. The word opposite in this case means across from the theta, the side that's not touching it. That's this side. Now I'm just going to use the letters OPP for opposite. So there's the labeling of this particular triangle. Now here's what sine, cosine, and tangent talk about taking two of the sides and making a fraction. That's why they call them ratios, because they're fractions. Sine is always the opposite side divided by the hypotenuse. So in this, it would be this length divided by that length. And I'll explain that with the board over here in a few minutes, like what does that mean? Cosine is the adjacent over the hypotenuse. Here's the theta, adjacent divided by the hypotenuse. And then the tangent is the opposite divided by the adjacent. Opposite divided by the adjacent. Okay, so those are called the trig ratios. Now, I shared what's known as this acronym before called SOHCAHTOA. Sounds like a weird word. It's really called an acronym, which means the letters in this weird word stand for something. Now, I wrote this a little bit different. I wrote it in like a weird fraction form so that you can remember the S stands for sine, this C stands for cosine, this T stands for tangent. The O is opposite, the A is adjacent, the H is hypotenuse. So if you look, this is just reminding you that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. SOHCAHTOA. And that's, I learned that when I was in school back in like 1986. Yeah. So anyway, that's that. Now, a couple things, and we're going to get to these triangles over here. If I take this theta and I move it to the other acute angle, and I say I want you to look at this angle and I want you to apply the labels to the sides. The hypotenuse never changes because the hypotenuse is about the right angle. The opposite and the adjacent switch position. See, this side is now touching the theta, so this side would have to be called adjacent now, which I'll just put ABJ. And this would have to be the opposite. And that is the one that's across from and not touching the theta. It's not part of this angle. The hypotenuse and the adjacent are. So that's a little bit of the labeling scheme. Now, here's what's important about that. So over here, I have 3 what I would call similar right triangles. And these triangles, believe it or not, they're drawn to scale. I drew them accurately. Okay? In this first right triangle, this side is 4, this side is 8, and this side is, to 3 decimal places, 6.928. All inches and accurate. I measured it with a yardstick. All right? I actually used this to literally measure these. And made sure that angle was 30 degrees. That's also accurate. And I use 30. There's a reason I use 30. It's easier to talk about. But anyway, here's another triangle. Right angle with a 30 degrees. This side is legitimately 6. This side's legitimately 12. And this is 10.392 to 3 decimal places. It is weird that that one side has to be a decimal. And then lastly, a little bit bigger. So a small, medium, bigger triangle. Still 30 degrees. Still right angle. This side's 9. That side's 18. This side is 15.588. Now here's the thing. Sine, cosine, and tangent can be used in situations like this if sides are missing. For example, if I had 30 degrees and only one of the 3 sides, doesn't care what, just I only knew one of them, I could use this trigonometry, sine, cosine, and tangent, to find that. Because here's the deal. Calculators have this programmed. See, I bet you're noticing something about, you're like, there's something about these triangles that looks similar. Did you notice that this side across from the 4, or across from the 30 degrees, I made 4 inches? Did you notice that the hypotenuse is exactly twice that big, 8? Or you could say this is exactly half the hypotenuse, 4 is half of 8. Did you then notice in this picture when I made this 30 degree angle and made this side 6, the hypotenuse came up exactly 12, double. 6 is half of 12. And then when I did this one, it happened again. This is 9, that's 18. 18's twice as big as 9. 9's half as big as 18. 6 is half as big as 12. That's not coincidence. If you make a triangle that's a right triangle with a 30, there's going to be similarity. 4 doubles to 8. 6 doubles to 12. 9 doubles to 18. Now, these other sides are a little bit different. They just don't turn out nicely. But I'll explain that. So, I want to focus on, if I were to ask you, what is the sine of 30 degrees? Instead of saying sine theta, theta is the angle. I actually know this angle's 30. I measured it myself. If I were to take out a calculator and do sine 30 degrees, like that. If you hit enter, it comes out 0.5. Well, let's think about that. I don't care which picture. Let's say sine 30 degrees. Let's say I said use the definition of the picture, meaning what's opposite divided by hypotenuse? In these pictures, across from the 30 is 4, the hypotenuse is 8. 4 over 8, 0.5. If I decide to use this triangle, opposite across from the 30 is the 6, the hypotenuse is 12. 6 over 12, opposite over hypotenuse. That's 0.5, just like the calculator said. Sine of 30 is 0.5. You guys, every triangle that I would draw with a 30-degree angle, I don't care if I drew a right triangle, that side over there was 15 miles long. The hypotenuse would be 30 miles long. If it's 30 and a 90. Has to happen. It's all symmetrical. It's similar. It's called proportional. All those good words. So over here, if I use that third triangle, and I said do sine, opposite over hypotenuse. Across and opposite's the 9. Hypotenuse is 18. 9 over 18 is 0.5. What if, and see the nice part, I am going to erase stuff here, but you can pause this video and look at it a minute, replay it, rewind it, back it up, whatever you got to do. But now I'm going to check, well, what about cosine of 30 degrees? By definition, cosine is the adjacent side divided by the hypotenuse. In this picture, let's use the little picture here of the 3. Next to the 30 is 6.928 and the hypotenuse is 8. Adjacent over hypotenuse. It's not going to look as nice. 6.928 divided by 8. Well, if I did that, I'm doing this one a little different. I'm going to do the 6.928 divided by 8 this time. 0.866. If I do cosine 30 on my calculator, because it's got it programmed in there, now you're going to see more decimal places, but the first 3 decimal places, 0.866. Once again, it means in every single right triangle that is a 30-degree angle, the adjacent divided by the hypotenuse will always be 0.866. So to spare you the writing of it, just hear me say it and show you. In this picture, that's adjacent, that's hypotenuse. So the cosine of this would be 10.392 divided by 12, 0.866. I already did it before we started this video. Over here, this big one, cosine 30, adjacent's the 15.588, hypotenuse 18. Adjacent divided by hypotenuse, this divided by that, 0.866. It doesn't matter the size of the triangle. Angles don't change. They can only be 30, 90. By the way, this would be 60 because 30 and 90 and 60 add to 180. So that has to be 60. And then if I wanted to show you again, lastly, I could do tangent. Okay? Opposite over adjacent. In this picture, opposite's 4 divided by adjacent 6.928. That comes out 0.577. I guarantee if I hit tangent 30 on this calculator, see, there's my tangent 30. If I hit enter, 0.577. There's more decimals because this is more accurate than just the sides, but it works. So that's just a demonstration that you got 3 different triangles, and again, I can't stress to you enough, I drew these accurately. These are measured in inches. That angle's 30 degrees measured out with a protractor, and you see what's happening. So I'm going to pause a minute and erase this and talk about one more thing. All right, so I'm going to finish with one final example about like how do you use this stuff for any practical purpose. Now, I've drawn myself another triangle. I didn't measure things out all perfectly this time because I didn't need to. This one I'm just going to use my common sense and logic and math to do this. Now I got myself a right triangle right here, right angles right here, and this angle's 37 degrees. And I chose a little bit more of an oddball. This is already programmed into a calculator to know what's going to happen, but see, this side is 19. And what trigonometry does is, like, they know what cosine 37 is, or sine 37, or tangent 37, whatever I'm going to use here in a minute. And it's going to help me find this length over here, because that's what we're going to do, is find x using trigonometry. Because if this side's 16 or 19 and that's 37 degrees, this has to fit it proportionally, and that's where trigonometry comes in. Now, I did draw this different, and I put the angle in a weird spot so you can understand how it happens. Now, the x, because here's the right angle, that's a hypotenuse. I'll just label that as HYP. Now listen, this 19, this side, touching the 37, next to, adjacent. Nothing's being asked about this side. I don't care about it, not even going to label it. And the reason is I want you to look at the two labels that are on this picture. Adjacent and hypotenuse. When you look at the three, sine, cosine, or tangent, you're like, well, which one uses adjacent hypotenuse? Which one uses A and H? A and H. Cosine does. Adjacent hypotenuse. Cosine. So we're going to take the statement cosine theta equals adjacent over hypotenuse. Except we're going to replace everything we know with the labels that are here. So it will be cosine 37 degrees. See, it's not theta. Theta is a variable if I don't know this angle. It's 37. Equals. The adjacent side is 19. The hypotenuse is x. And here's the deal. Put this over 1. So that it looks like fraction equal fraction. You can always put something over 1 to make it a fraction. If you have a fraction equal to a fraction, cross multiplication works as a solving method. That means whatever this multiplies to has to equal whatever this multiplies to. Rule of thumb that I apply, I always do the cross multiplication where the x or variable is first, which means I'll do here. That is x times cosine 37 degrees. That has to equal the other cross multiplied. 19 times 1 is 19. And I'm going to solve this equation. Now, the variable I want it to say x equals, has something multiplied to it, cosine 37. If you're ever solving and it's times, you divide both sides to get rid of that. So we are going to divide by cosine 37 degrees, divide by cosine 37 degrees, out, see, reduces, there's an x. You have to let your calculator help you because it's programmed with the cosine 37. So we're going to do 19 divided by cosine 37. That's what it's going to look like on the screen. Hit enter. Approximately 23.7 something. I got to look at it and I'm going to write it down. But that's what that side is, 23.791. And that's what trigonometry will do for you. If you have a right triangle with an angle and one side, the rest of the sides have to fit proportionally to that 19 and make everything work. And that's what happened right here. So there's where SOHCAHTOA, sine, cosine, and tangent come into play, because the 37 degree angle provides sides that can only be either so big or so little or whatever. So there's I hope a better an explanation of how trigonometry starts. It's just an introduction, but it's a big branch of mathematics that we use. All right. Hope this helped out, folks. Take care of yourselves.